to 0, 1 minus cos of 1 minus cos x by 2 divided by 2 raised to lambda into x raised to mu is equal to left hand derivative of y is equal to e raised to minus mod x at x is equal to 0. Then find lambda and mu. Here this is 1 minus cos x by 2 is the angle theta, right? Now the standard limit, one limit theta tends to 0, 1 minus cos theta by theta square is equal to 1 by 2. And here is mod x. Mod x is equal to x if x greater than or equal to 0 is equal to minus x if x less than 0. Okay. Now, the value of this limit is equal to the LHD of this function. Now, consider y. Y is equal to e raised to minus mod x. This implies y is equal to e raised to minus for x greater than or equal to 0. The value of mod x is x. So, e raised to minus x. And this is equal to e raised to minus of minus x for x less than 0. That is e raised to x for x less than 0. So we can write this y is equal to e raised to minus x for x greater than 0 or e raised to x for x less than 0. Then left hand derivative is equal to dy by dx of this term e raised to x at x is equal to 0. Now d by dx of e raised to x is equal to e raised to x. So this is equal to e raised to x at x is equal to 0. That is equal to e raised to 0 is equal to 1. So value of this limit is equal to 1. Now we want to find this lambda and mu. That is the question. We can write this limit x tends to 0, 1 minus cos of 1 minus cos x by 2. Changing into standard form. So I am dividing this by 1 minus cos x by 2 the square whole square. 1 minus cos x by 2 the whole square. That is 1 minus cos theta by theta square. So as to balance the equation, we have to multiply the numerator with this term. That is this numerator into 1 minus cos x by 2 the whole square divided by the rest of the term. That is 2 raised to lambda into x raised to mu. This is equal to 1. The value of this limit is equal. This is equal to limit x tends to 0. Instead of this limit, put the value as 1 by 2 into 1 minus cos x by 2 all square. So this divided by theta square. Theta square is x square by 4. Here theta is x by 2. Into again 1 more 1 minus cos x by 2. That is 1 minus cos x by 2 divided by x square by 4. So as to balance the equation, this should be multiplied by x square by 4 into x square by 4. This divided by 2 raised to lambda into x raised to mu is equal to 1. Now value of this limit. Value of this limit is equal to 1 by 2. And this limit also is equal to 1 by 2. The rest, then now limit x tends to 0. 1 by 2 into, the value of this limit is 1 by 2. The value of this limit is 1 by 2. Into 4 into 4. X raised to 4 by 16. That is, 16 means 4 into 4. That is equal to 2 raised to 4 into 1 by 2 raised to lambda into x raised to 4 is equal to 1. So this is equal to limit x tends to 0, 1 by 2, how many times? 1, 2, 3 in 4 into, this is equal, this can be written as 2 raised to 1 plus 2 raised to 1 plus 2 raised to 1 into 2 raised to 4. That is equal to 2 raised to 7 into 2 raised to lambda. So lambda 7 plus lambda into this term, this is x raised to mu. X raised to mu, this 4 is taken in the denominator, that becomes mu minus 4. That is equal to 1. The value of this limit is equal to 1 when this is equal to 1 and this is equal to 1. This should be 1 and this should be 1. This is equal to 1 implies 2 raised to 7 plus lambda is equal to 1, or 2 raised to 7 plus lambda is equal to 2 raised to 0. Comparing the powers, 7 plus lambda is equal to 0, or lambda is equal to minus 7. X raised to mu minus 4 is equal to 1. That implies x raised to mu minus 4 is equal to 2 raised to 0, or mu is equal to 4. Therefore, lambda is equal to minus 7 and mu is equal to 4. If f of x is equal to sine x square by x, if x not equal to 0 is equal to 0, if x is equal to 0, check differentiability at x is equal to 0. Left hand derivative, that is f dash 0 minus, is equal to limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. This is equal to limit h tends to 0. Here x is replaced by minus h. That becomes sine of minus h the square divided by minus h minus f of 0. F of 0 is given as 0 divided by minus h. That is equal to sine of h square divided by minus h into minus h, that becomes h square. Limit h tends to 0. This is form limit theta tends to 0, sine theta by theta is equal to 1. So this is equal to limit. So this value of this limit is equal to 1. Now right hand derivative, that is f of 0 plus is equal to limit h tends to 0, f of 0 plus h minus f of 0 divided by h. The value of this is equal to 1. Right. This is equal to, now replace x by h. Limit h tends to 0, sine h square divided by h minus f of 0, that is equal to 0 by h. That is equal to limit h tends to 0, sine h square divided by h into h square. That is equal to 1. This means LHD is equal to RHD. So the function is differentiable. If it is differentiable, imply the function is always continuous at x is equal to 0. F of x is equal to x sine 1 by x. If x not equal to 0, if x is equal to 0, check continuity and differentiability. Checking continuity, find left hand limit and right hand limit. It is equal to f of 0 minus, that is equal to limit h tends to 0, f of 0 minus h. That is replaced x by minus h. That is equal to minus h into sine of 1 by minus h. That is equal to h into sine 1 by h. Here limit h tends to 0. This is equal to 0 into sine 1 by 0. That is 0 into sine infinity. What's the value of sine infinity? Sine infinity is equal to minus 1 to 1 closed interval. That is any value between minus 1 and 1. That means this is oscillating value. So we have multiple answers. This implies this is equal to 0 into closed interval minus 1 to 1. 0 into 1. So 0 into anything, that is equal to 0. This is equal to left hand limit. Right hand limit, that is f of 0 plus is equal to limit h tends to 0, f of a plus h. That means a is equal to 0, 0 plus h. To replace x by h. Limit h tends to 0, h into sine of 1 by h. 0 into sine infinity. That is 0 into sine infinity is minus 1 to 1. This is equal to 0. Means LHL is equal to RHL. What is the value of the function? Value of the function f of 0 is given as 0. That is LHL is equal to RHL is equal to f of 0. Implies function f of x is continuous at x is equal to 0. Check the differentiability. To check the differentiability. That means left hand derivative is equal to f dash 0 minus, that is equal to limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. That is equal to limit h tends to 0. That is replace all x by minus h. This becomes minus h into sine of 1 by 0 minus h. That is minus h. F of 0 is equal to 0 divided by minus h. This minus h and minus h get cancelled. So this becomes limit h tends to 0 sine of minus 1 by h. That is equal to minus sine 1 by 0. So the minus of sine infinity. That is minus of minus 1 to 1. This you can take any value in between minus 1 and 1. That means LHD does not exist. So function is not differentiable. But this function is continuous. What? Continuous. A function to be differentiable, then LHD is equal to RHD, and both is equal to a finite value. Here we have got a multiple answers. This is an oscillating value. If a function is differentiable, then LHD and RHD are finite and equal. That is LHD, that is f dash a minus is equal to f dash a plus is equal to finite value. If a function is differentiable, if a function is differentiable, it should differentiable at a point. Then it should be always continuous at that point. But if a function is continuous, it may or may not be differentiable. That means differentiability guarantee continuity. That means function is differentiable, it should be continuous. But continuity never guaranteed differentiability. If its function is continuous, it may or may not be differentiable. Is equal to x square plus 2x for minus 2 less than or equal to x less than minus 1. Is equal to minus 1 for minus 1 less than or equal to less than x less than 0 is equal to 0 for 0 less than or equal to x less than 2 is equal to x square minus 2x for 2 less than or equal to s less than 3. Check continuity and differentiability of f of x in the interval minus 2 to 3. We need to check the continuity and differentiability in the closed interval minus 2 to 3. So this endpoints minus 2 and minus 3 need not be considered or need not be checked. So we need to check continuity and differentiability in the open interval minus 2 to 3. No need to consider endpoints. No need to check at endpoints. or checking points are -1, 0 and 2. Now checking the continuity at x is equal to -1, left hand limit LHL is equal to f of -1 minus, that is equal to this, that will come under this function, that is equal to -1 square plus 2 into -1, that is equal to 1 minus 2 is equal to -1. RHL, that means f of -1 plus is equal to -1 plus means under this point, that is equal to -1. That is LHL is equal to RHL is equal to f of -1. Since f of -1 is -1 is equal to -1. So implies continuous at x is equal to -1. This is continuous. Now at x is equal to 0, left hand limit is equal to 0. The left hand limit is coming under this portion. So that is equal to -1. And right hand limit is equal to 0. 0 less than or equal to, so it is equal to 0. And also f of 0 is equal to 0. LHL not equal to RHL implies not continuous at x is equal to 0. That is discontinuous. Here it is continuous. Now at x is equal to 2, LHL is equal to 0 and RHL is equal to, coming under this function, 2 square minus 2 into 2, that is square minus 4, that is equal to 0. And the value of the function is equal to x square minus 2x, that also is equal to 2 square minus 2 into 2 is equal to 0. And f of 2 is also 0. So LHL is equal to RHL is equal to f of 2. This means continuous. This means continuous at x is equal to 2. Continuous at x is equal to -1 and x is equal to 2. Now f dash x is equal to, for this value, 2x plus 2 for -2 less than or equal to s less than -1. For the derivative of a constant is equal to 0. So this is equal to 0 for -1 less than or equal to s less than 0. And again 0 for 0 less than or equal to s less than 0. The derivative of x square minus 2x is equal to 2x minus 2 for 2 less than or equal to x less than 3. The differentiability at x is equal to -1. Left hand derivative is equal to f dash of -1 minus, that is equal to, this is coming under this value, is equal to 2 into -1 plus 2, that is equal to 0. Now right hand derivative is equal to, coming under this, that is equal to f dash -1 plus is equal to 0. LHD is equal to RHD, imply differentiable at x is equal to -1. At x is equal to 0. LHD is equal to 0. And RHD is equal to 0. So, differentiable at x is equal to 0. Now, at x is equal to 2, LHD is equal to 0 and RHD is equal to 2 into 2 minus 2, that is equal to 2. LHD not equal to RHD, so not differentiable. Therefore, f of x is both continuous and differentiable at x is equal to minus 1 only. F of x is equal to minus x minus pi by 2 for x less than or equal to minus pi by 2 is equal to minus cos x for minus pi by 2 less than x less than 0 is equal to x minus 1. 0 less than or equal to x less than 1 and ln x for x greater than or equal to 1. Check continuity and differentiability for R. R is a set of real numbers from minus infinity to infinity. Continuity and our checking points are x is equal to minus pi by 2, 0 and 1 is equal to minus pi by 2. Left hand limit is equal to this value, that is minus of minus pi by 2 minus pi by 2, that is equal to pi by 2 minus pi by 2 is equal to 0. Right hand limit is equal to, that is f of minus pi by 2 plus is equal to, approaching from right side, minus cos of minus pi by 2 is equal to 0. That means, and the value of the function f of minus pi by 2 is equal to minus cos pi by 2 is also equal to 0. Since LHL is equal to RHL is equal to f of minus pi by 2, that's the value of the function. This implies continuous at x is equal to minus pi by 2. So this is continuous. Now, at x is equal to 0, left hand limit is equal to f of 0 minus, that is equal to minus cos 0 is equal to minus 1. Right hand limit is equal to f of 0 plus, that is equal to 0 minus 1 is equal to minus 1. That is f of 0 minus is equal to f of 0 plus is equal to f of 0. This implies function is continuous at x is equal to 0. At x is equal to 1, left hand limit, that is f of 1 minus is equal to x minus 1, that is 1 minus 1 is equal to 0. right hand limit is equal to f of 1 plus that is equal to ln 1 is equal to 0. And the value of the function for x is equal to 1 is also ln x, that is ln 1 is equal to 0. That is LHL is equal to RHL is equal to the value of the function f of 1. This implies continuous at x is equal to 1. F dash x is equal to, in this for x less than or equal to minus pi by 2, the derivative of this is equal to minus 1. Derivative of cos x is equal to minus sin x. So minus of minus sin x is equal to sin x. It's equal to sin x for minus pi by 2 less than or equal to s less than 0. For derivative of x minus 1 is equal to 1. 1 minus 0. For 0 less than or equal to x less than 1. And derivative of ln x is equal to 1 by x. For x greater than or equal to 1. Okay. Now checking the differentiability. At x is equal to minus pi by 2. Left hand derivative is equal to minus 1. Right hand derivative is equal to sine of minus pi by 2 is equal to minus sine pi by 2, that is equal to minus 1. LHD is equal to RHD. This implies differentiable at x is equal to minus 2 pi by 2. This function is differentiable. X is equal to 0. At x is equal to 0, LHD is equal to coming under sine 0. Is equal to sine 0 is equal to 0. And RHD is equal to 1. LHD not equal to RHD. So not differentiable at x is equal to 0. This is not differentiable. This is differentiable. Now at x is equal to 1, HD is equal to 1. And RHD is equal to 1 by x, that is 1 by 1 is equal to 1. LHD is equal to RHD, that is differentiable. Differentiable at x is equal. So f of x is both continuous and differentiable at x is equal to minus pi by 2 and x is equal to 1.